Okay, so this is worksheet 3.3 for separation techniques. So let's go through the answers. So question 1, if salt is mixed with water, what's the type of mixture form? Because the salt will dissolve in water, so we call it a dissolved solid liquid mixture. Now, what is the one-step method that could be used to obtain salt from the salt water? Okay, so we know that for the one-step method is actually called evaporation dryness. Literally, you just heat the solution up until all the water is gone, and what you're left with is the salt. So this is the diagram that you can draw here. You can find it on page 33. So please make sure you draw it correctly. Now, how different is crystallization from evaporation to dryness? So crystallization is another method used to obtain the dissolved solid. So in crystallization, the salt solution is not heated until dry. So just like evaporation dryness, okay, so in evaporation or dryness, you heat it up until all the water is gone, until you're left with only the crystals, or the salt. Now for crystallization, okay, you will not heat until dry. Instead, you heat it up until most of the water has boiled off. So typically in this case here, what you're going to get is something like this. So there's still some water there, okay, but you'll start to see some solids at the bottom. Okay, this is what we call a hot saturated solution. So when it's hot, they are already solid form, but there are still some liquid left. So we call this a hot saturated solution. Once it reaches this state, we'll let it cool. And as it cools, we actually have pure crystals forming inside over here. So that is the difference between crystallization and evaporation to dryness. So what's the advantage? Now do take note, crystallization will actually help to obtain a pure solid sample. Okay, while evaporation and dryness may have some impurities, because when you heat all the water disappear. When you heat up all the water to evaporate, actually what you have here is all the dissolved solid. All the dissolved solid here may contain salt, but may contain other substances that we do not know. So it contains salt plus other impurities. But for crystallization, because it gathers around the main salt, okay, the crystals form actually is all the same type of particles, which is the salt that you want. So actually you get a pure solid sample. Do read up more a little bit. Next one, crystallization can be formed for substances which may decompose on strong heating, or evaporation to dryness may cause the substance to decompose. Example, sugar. If you use evaporation to dryness for sugar, what happens is the sugar, you know that when you heat it up, it will decompose. So what's happening is that if you use evaporation and dryness for sugar, it will decompose, whereas you can actually collect the sugar crystals back if you use crystallization method. Okay, next. Now, so instead of collecting the solid, is it possible to collect just the liquid itself? Okay, so the top is actually used to collect the solid. Okay, solid. The bottom here, we're going to look at, once again, the dissolved solid liquid mixture. But what I want the liquid. I want the liquid. So what method should I use to get the liquid? It's actually simple distillation. So what's the solute? What's the solvent? Solute is actually the dissolved solid. Okay, solute is actually the liquid. So this is a distillation setup. So typically you heat up, so you store your mixture inside here. So this is actually salt water. You put some boiling chips inside here. And as you heat up, the water will actually boil, become gas. It will come all the way up here. The thermometer is used to measure the temperature of the gas that's coming out. So that as the gas comes out here, this thing here is called a condenser. The water comes in here, goes out here. Or it will actually cool the gas down. So along the way here, the liquid will condense. That's why it's called condenser. And when it condenses in droplets, it will come out. This is what we call the distillate. Okay? So this is a distillation setup. Okay, so do take note, learn to draw it. Now explain why was the following procedures done for the distillation setup. So you add boiling chips. Why is it so? This is to ensure smooth boiling. Because sometimes when the boiling gets very vigorous, the whole thing vibrates and it may cause your setup to topple, or it may cause your setup to, be unstable. Next one, the bulb of the thermometer is placed beside the side arm of the distillation. So you can see thermometer is placed beside this is the side arm. Okay, so thermometer is placed just beside the side arm. Why is it so? This will ensure that we are measuring the boiling point of the substance that's being distilled. Imagine you put it in here. Thermometer is long enough to reach here. You're actually measuring the boiling point of the salt water. That's not what we want. We want the boiling point of the gas that's coming out. Okay? Next one, the condenser should slope downwards. I think this one makes sense here, so that the liquid, when it condenses, it will flow down towards the conical flask over here, the receiver. And last one, the water enters from the bottom and then exits from the top. So the cold water enters from the bottom, exits from the top. This is really very much about the efficiency of cooling. So this actually provides a more efficient cooling system. Okay? Now, so in summary, what can we use to separate the following mixture? Because we're learning about separation technique. In the previous worksheet, you actually learned about filtration. So we can actually separate the undissolved solid from the liquid using filtration. For dissolved solid liquid mixture, actually you realize there are three different methods: evaporation to dryness and crystallization. This two is to collect the solid. Simple distillation is normally to collect the liquid. Okay, so this is your worksheet 3.3.